Thanks for everybody for joining. Top of the morning to you. I guess that's fitting on today. Happy St. Patrick's Day. Real excited about the information we're going to share with everyone on the line. Thank you, Grant or Reef, whoever put that slide deck up. Read my mind. I'm Nick Marcarelli. I'll be getting us kicked off today. We have a quick little introduction, a couple logistics things, and then we will jump right into the content around advanced cluster management. Grant or Reef, whoever's got the controls, can you, there it is. Perfect. Go ahead to the agenda side real quick. There we go. Thank you. So we're going to do quick introductions. Going to share a couple of resources that we have with you. Going to quickly talk about Shadowsoft's Kubernetes Center of Excellence, and a little bit around the market trends and challenges. And then I'm going to pass it over to the smarter guys on the call to dive into advanced cluster management for Kubernetes and all the stuff people are probably here to really learn about. Next slide, please. Again, I'm Nick. That's the best smile I've ever had, so lucky for everyone on the webinar. We've also got Grant Dellavecchia and Arif Wanata with Red Hat joining and helping out with the technical parts of the discussion. Shadowsoft, we're a Kubernetes integrator. We're very focused on our Red Hat partnership, specifically around OpenShift. So if that's why you're here, we're excited you're here. We're focused on helping customers around the adoption lifecycle in Kubernetes in general, along with the other solutions in Red Hat's portfolio. Next slide, please. Real quick, Kubernetes Center of Excellence. This is a program that Shadowsoft launched a few weeks ago. If you were on a previous webinar, you may have heard about this. kubecoe.com will get you to the informational page around that. But basically what we've been doing for the last collection of years is helping customers on their journey with Kubernetes. And we've learned some things along the way. And we have productized that into a solution that consumers can work with us around. What I'm showing you here is a simple, icon workflow of how we see the world. We believe it starts with a comprehensive health assessment, building operations playbooks for readiness around your clusters and your plan and all of your tooling, working with developers on how to build applications that are specifically built for Kubernetes and the differences in that, and then making sure that they communicate back with operations. So there's this cohesive working relationship between the two groups. Monitoring and orchestration. So we help with tooling, best practice guidance around the type of observability and monitoring you would want related to Kubernetes, how you integrate that into your existing investments. And then coming very soon, Shadowsoft's Academy for KubeCoe is focused on upskilling your team, your teammates. So customers that are part of this program will get access to reference materials, training videos, lab demonstrations around how we do the Kubernetes. So this is a new program that we've actually, that we've put out to the public, but it's something we've been doing for 4 or 5 years. So this is our bread and butter. This is what we focused on. And, so if you have any, interest in that, want to talk about it, want to understand more about what's involved, please let us know. You can go to the website, download reference material. There's a contact form, all that good stuff. Next slide, please, Grant. Last shameless plug, I host a podcast on behalf of Red Hat and Shadowsoft. It's called Application Modernization. We talk to lots of smart people and lots of different parts of the technology sectors, whether they're end customers or they're integrators or they're thought leaders in the space. We're putting out, between 6 and 8 podcasts a quarter. So great library available wherever you get your podcast. Please subscribe, listen, hopefully learn some cool stuff. we really try to go very, very broad. So it's not focused on just a singular thing. We tackle things into crypto and the metaverse and, the emergence of public cloud, like where is it going? How is it going? All types of things. So I think it's a pretty good listen. I may be biased because I host it, but give it a listen if you will. Next slide, please. So before I get into this, couple logistics. If you registered ahead of time and confirmed, you will be getting a DoorDash gift certificate so that you can order lunch, whether that's today or a future date. It's a digital certificate. So thank you for doing those things. If you've joined and you didn't confirm, you will not be seeing that. That's a bit of the process is us planning around that. So next time, please confirm, and then we will be doing a drawing for some Apple AirPod Maxes in the next day based on who's attended this webinar, and we'll let you know when that gets done and get your shipping information. All right, market trends and challenges. Next slide, please. So, the whole point of going over Red Hat's ACM product is, the hybrid multi-cloud management challenges are, as the slide says, most organizations are not just picking one public cloud. They're definitely straddling applications across various infrastructure, whether that's public cloud resources or on-prem in their data center or their colo. This is a challenge I think everyone has. Very few organizations are actually just doing it one way, or they're born in the cloud, right? So there's always going to be this challenge, and having the right tools in place to do that makes a lot of sense. If you're standardizing on Kubernetes or OpenShift in this case, running that in the public cloud and on-prem is a great way to do that, to abstract away the complexity for your developers. So this is a real topic that we talk to customers about every day. Obviously, IDC has put out a bunch of surveys. I'm not going to read it to you because everybody can read, but this is the challenge in the marketplace right now. Next slide, please. So same with Kubernetes, right? No one typically has one flavor. Sometimes these projects start as a pilot. It might be in a public cloud service like EKS or AKS or GKE. And then when it becomes a de facto standard within an organization, they may choose to do that on-prem along with what they've done in the public cloud. So the multi-cluster, the multi-flavor of cluster is becoming a very normal use case. Also, when you look at organizations that are acquiring other organizations, you're acquiring those technical assets and infrastructure and all those complex things that have to be integrated in. That has its own set of complexity. So I think very rarely are we going to find that an organization has specifically just picked one path and that's the only way that they live through it. Next slide, please. So, cluster deployments across different organizations are really, really interesting. We would talk about, medium scale to enterprise, typically in Shadowsoft's group of customers. So when you have a medium scale organization, depending on your vertical, you might have separate needs like office locations across the country or the world, and you may have independent clusters set up to support those operations. From a large scale perspective, this is probably the easiest use case to think about. You think about retail, for example. They have locations everywhere. We see this as a very common trend that every store is going to have their own set of infrastructure. It's gonna look similar, but it has to be independently managed. And then you go to the furthest extent where we talk about Kubernetes on the edge, and you look at telco, right? Like you look at Verizon, for example. They have all these things in the field that need to capture data and process data, and they're doing that on the edge with Kubernetes. So that becomes increasingly complex when you talk about thousands of clusters around the world. Next slide. This is pretty self-explanatory. why do we deploy clusters? These reasons, right? There's always these business cases, but if you just have one, you lack redundancy. You're deploying clusters on the edge for obvious reasons, probably for compute power and collection, and then serving that data up somewhere else. These are all core concepts to why we see the growth in Kubernetes in the space today. Next slide, please. So here are some of the, these are the multi-cluster management challenges. It's really about having a central view. So the common IT term around this is a single pane of glass, which is, that's fine. We've all been saying that for a decade at this point. But really it comes down to the latest trend, which is observability. We need to know what we have. You can't manage what you can't see. So when your organization is out there and they have a standard for on-prem, and then they have a standard for public cloud resources, and then they have a different standard for the edge, that can become really challenging. Those might be three functional groups. Who's the interconnect between all of those clusters? And the answer around that is, advanced cluster management, especially when we're talking about public cloud Kubernetes services and OpenShift. So you can have a strategy with multiple flavors. The question is, do you have a tool to help you wrangle all of that? And from there, I think I'm pitching to Grant.
Technically a reef.
Oh, technically a reef. Very good.
Yeah.
But somebody knows what's going
on. Well, thanks, Nick, for the good intro. So hey, everyone, just to quickly quote it, what Nick just said just now, 1,000 of clusters. You need to know what you have. You need to know what's running where, right? That's kind of the challenges that we all see every day when dealing with multiple Kubernetes clusters, right? And before I begin, my name is Arif Winata. I'm Solution Architect at Red Hat. I will be 5 years in this coming July, so it's been a while. And I work closely with the Shadowsoft team, basically a support a number of partners, and it's been great really working with the folks at Shadowsoft, with Nick, with Grant, with Casey as well. And thanks everyone for tuning in today. We tried our best not to do death by PowerPoints. I mean, trust me, I cut down all these slides because this is one of the products that it's better to see it in action, that sort of things. But then again, we'll get into that. But we're just going to make sure that we all can send across the messaging. What can we do with ACM, right? So let's do that first. So if you can move to the next slide, Grant. All right. So now let's talk about the Red Hat Advanced Cluster Management for Kubernetes. I know it's kind of a mouthful, so I'm just going to refer it as Red Hat ACM or just ACM, if you will. So ACM provides end-to-end management of Kubernetes environment. I think Nick said it best. It's a single pane of glass, if you will. I know it's a term that we always use, but hey, we have to start somewhere, right? Another word of describing it is it's a single dashboard or console where you can control all your Kubernetes clusters, whether your clusters are in the data centers or in hybrid clouds and hyperscalers, right? And when we talk about data centers, also bare metal is fine, virtual machines fine. Also talk about hyperscalers, I mean things like AWS, Azure, Google. Now ACM can help you manage all of your clusters running on any of these platforms or environments. The ACM software itself, it's a piece of software that runs on an OpenShift cluster, so it's something that you install, right? And it's being sold as a software subscription. I mean, if you're familiar with the rest of Red Hat's portfolio of products, for example, RHEL, which is Red Hat Enterprise Linux, or OpenShift itself, we sell them in the form of subscriptions, right? So the default mode of software consumption, subscriptions. And with ACM, typically there are 4 main use cases that we can address by using it. But really, all these 4 use cases, they boil down to simplifying the day-to-day management of multiple Kubernetes clusters, whether you have 3 or 300 clusters, 10 or 10,000 applications and containers running on the clusters. ACM can help you with managing those. And as I said before, there are quite a few slides that we go through our presentation today, but if you could just take one slide out of today's session, right, this should be it. And these are the 4 main use cases of ACM. And first and foremost is the multi-cluster lifecycle management. And this is basically giving you the ability to manage your Kubernetes clusters from cradle to grave, right? From start to finish, from commissioning to decommissioning. Second one is policy-driven governance, and this is something that you can have in order to apply policies on your clusters, right? And we'll look at this later in a little bit of details. I mean, when we mention policy, usually people start thinking about security, but there are more things beyond security that you can do to kind of apply policies for your clusters. Next one is advanced application lifecycle, or I usually call it just application delivery. And this is a cool thing, basically deploying, maintaining, distributing applications across a fleet of clusters. And last but not least, it's the observability, basically monitoring, hey, I want to see, I've got 1,000 clusters, but I want to see which one are not healthy, which one can be optimized or improved, and things of that nature. All right, let's talk about each of these use cases in a little bit of detail. Then we move to the next slide, Grant. Okay, so with the multi-cluster lifecycle management use case, typically these 2 personas are the ones who likely going to be primary users of these functions. I mean, we have folks from IT operations, and some of them probably come from the NOC, or Network Operating Center, who are typically interested in kind of 30,000 feet view of the environment, right? I mean, are my clusters healthy? Are the applications running efficiently? Is there any of my clusters running more than 80% capacity? I mean, these are the things that typically they worry about. And folks from the DevOps side of the house, and typically they're involved in both areas of development and operation, and these roles are more prominent nowadays, since almost every developer I talk to say, hey, I want to be able to order my environment at will, right? Because I'm working all these multiple projects, and for all of these projects, I need a dev environment, right? I need a QA environment. I need an environment to stress test my code, right? And then followed by deploying their codes into these environments after they, created it. And they want to be able to use the same single interface to create clusters, as well as upgrade the version of the clusters, maybe, as well as deploying applications, right? And all of these functionalities are made possible with ACM because, again, it's a single pane of glass. Next slide, please, Grant. So what can we do with ACM to manage clusters, to facilitate cluster lifecycle management? And first and foremost, you can do things like basic stuff like creating clusters from scratch, right? Deleting clusters, maybe updating clusters to specific versions. And in relation to this, there is a nice feature in ACM where you can attach labels to your Kubernetes clusters. And for example, a label can be my env equals to dev, right? To label like, hey, this cluster is for development, or my env equals to prod. Okay, this one is production. My app equals to Pac-Man app. I'm sure everyone knows the game Pacman. And I'm gonna use this Pacman app as an example for the rest of the presentation. But yeah, you can label, you can attach a label to your cluster, says my app equals to Pacman app, right? And with ACM, you can really use these labels to perform a variety of tasks. Again, we'll see a little bit of example in the video later. For example, if you deploy an application, and again, we will look at application delivery in later slides. If you deploy an application called Pacman to any of the clusters which have my app equals to Pacman as a label, right? Not only that Pacman application will go to that cluster, but going forward, as and when you launch a new cluster with the label of my app equals Pacman, once that cluster is up and running, the Pacman app, guess what? It's going to be deployed to that cluster and will become up and running. I think that's neat and really can make life easier for making sure that your applications get deployed to the correct clusters and running correctly. Right? Next function with ACM, you can stop and start clusters. Okay, this is a nice feature to have. Perhaps you're being charged by the hour if you're renting compute node somewhere, and at times you want to reduce your utilization to reduce expenses, stuff like that. All right. Now, what kind of Kubernetes clusters can we control and manage with ACM? Well, first of all, of course, I want all my customers to just run OpenShift cluster, right? OpenShift Container Platform, or OCP. Generally speaking, most of the customer I work with, if they're on OCP, usually they run version 4. I think the latest one is 4.10 something, right? But version 3.11, it's still supported as well, although we're kind of getting out of its limited support. So if you're still running 3.11, I would definitely recommend you to upgrade to version 4, because that's the version we currently focusing our development efforts on. So those are definitely supported by ACM. Now, OpenShift is also available as managed offerings. So a lot of our customers, they don't want to deal with all the problems that comes with managing, or call it the upkeep of maintaining own servers, right, or own data center, whether it's private or renting from some other company. So to cater to these customers, we made OpenShift available as an offering through a number of hyperscalers. For example, we have ROSA, which is Red Hat OpenShift on AWS. We have an offering with Azure, which is called ARO, Azure Red Hat OpenShift, and also a few others with other hyperscalers. So Kubernetes clusters running on these offerings can also be controlled and managed by ACM. Now, in addition to those, typically what happens with each of the hyperscalers, right? They also have their own Kubernetes offerings. Now, they're not OpenShift, but they're still 100% Kubernetes clusters. So, for example, Amazon has got EKS, Azure has got AKS, Google has GKE, and all of these Kubernetes clusters can also be managed by ACM. So as you can see, ACM is very flexible in terms of what types of Kubernetes clusters you can control, also where they're running on, right? Whether they're on data center or on hyperscalers. But how about Kubernetes clusters in our customer's data center, right? Next slide, please, Grant. On the data centers, typically we'll find things like bare metal, right, and virtual machines. Now, bare metal servers are also supported, right? Many of our customers, typically in I would say financial sector, where they usually want to minimize latency and all that, and they haven't really gone into virtualization, they still run bare metal servers, and perhaps in addition also to virtual machines. So bare metal is no problem. And speaking about virtual machines, VMware or vSphere are also supported too, right? Again, ACM is very flexible with cluster lifecycle management. Whether you cluster in data center, yes, no problem. In public cloud, yes, no problem. Just now we learned that we can use ACM to create new clusters, but what if our customers, or what if I have an existing, maybe multiple existing Kubernetes clusters when I start using ACM? Again, no problem with that. Not only we can use ACM to launch or spin up new clusters, but we can also import existing Kubernetes clusters, right? We don't have to start it from scratch. And again, whether they're existing OpenShift or AKS or GKE, you can import them all. What's that term? Resistant is futile, right? Comes from a movie or one of my favorite TV shows. Next slide, Grant. This is the last piece about multi-cluster management I'm going to talk about today very quickly. And this is about metrics, right? We all know when you operate a clusters or even like servers, right? It pays to aggregate your logs and try to data mine, if you will, those logs to see or rather to predict issues before they can impact your business. And this is also included with ACM. So this is a telemetry function that comes with ACM, basically various data, logs, and stuff like that that comes from running clusters are being collected. And we included Grafana, which is an open source software too, just like OpenShift or ACM itself. Now Grafana, we use Grafana to process and display the data analysis based on all these multiple inputs, right? And if you've used Grafana before, it's pretty cool. I mean, there are a lot of things you can do with it. It's all graphical. ACM gives you predefined metrics that comes, by default, and therefore you can do things like, hey, give me a holistic view of the health status of all my clusters, right? Or you can create a custom alert rule to warn you if maybe certain capacity threshold has been reached, maybe 80%, 90%, right? You want to be notified before it reached to a dangerous level. So from that perspective, monitoring, things like that, it's all included in ACM as well. I'm just going to pause here for a few seconds to have a sip of water and to check the chat if there's any question from the audience. All right, looks okay. All right, now, next slide, please, Grant. Right, so we looked at how we can manage cluster lifecycle with ACM. Now let's look at the policy and compliance feature of ACM. And this is where ACM gives us the ability to create and apply policies to our clusters. For example, we can apply specific security policies to our clusters, right? We can ACM, with ACM, we can also find out through dashboard, for example, how many violations of policy that we have at any time. For example, hey, show me which clusters somehow drifted from its original configuration, right? I'm sure that happens a lot, configuration drift. And talking about security also, we all know that security has been the center of attention lately. I mean, since the lack of security can really impact businesses, I mean, you take a pick from just impacting your business or reputation or even monetary or all three together, right? So it's kind of pretty important that we pay a lot of attention to security. Next slide, please, Grant. So with ACM, we can implement policy-driven governance. We can centrally, again, from the single location, we can set and enforce policies for our clusters, for our applications, basically via the cluster infrastructure. And by default, ACM is packaged, is bundled with a set of policies that are either ready to deploy or maybe you just need to modify it a little bit and deploy, right? And you can also, in addition to that, create your own from scratch or import from many sources or repositories, perhaps a community repository where people upload their policies that they find useful, right? And all these policies are all in YAML form, so there's a standard for that, and it's really easy to develop from scratch. Now, what are the real world example for this? So a policy can be as simple as, let's say, a kubeadmin policy, right? You write a policy or you just deploy a policy to make sure that the default kubeadmin user, if you deploy a Kubernetes clusters before, you know that after you launch your cluster, after you install your cluster, there will be a super user or root user called the kubeadmin. We can write a policy to say like, hey, I want to know if there is any default kubeadmin user in my clusters, right? Typically, we want to remove that because this is like disabling root users to your Linux servers, right, to improve security. And typically, I mean, this is my best practice anyway. When I launch a new cluster, I usually just remove the kubeadmin user and then replace that with just a normal users. But then we'll give special privileges to that user, right? So that's a better way of doing things. So again, you can write a policy to enforce this on all your clusters. Another example of a policy which probably not directly relevant to security, let's just say OpenShift version policy. So for example, you can set a policy where you enforce that, hey, for every cluster that runs OpenShift version 4.7, for example, it needs to be running version 4.7.23, for example, right? So you can do that. You can view, hey, which ones are 4.7, and then for all those from 4.7, which one are compliant with your rule that it needs to be 4.7.23. I think that's pretty neat. And really, everything is visualized. So you go to a dashboard, you can see which ones of the policy applied to which clusters, and then which clusters are being compliant or not. And again, it's very, it's very neat feature to have. And also another thing to mention that ACM plays very well with Ansible, right? With Ansible automation platform. So for example, if you have lots of things to remedy based on your policies, right? You can write a playbook, and then with the help of Ansible automation platform, you can really schedule that or automate those tasks to remedy those things in order for your clusters to be compliant with your policies. It's pretty cool. Next slide, please, Grant. Okay, this is the last bit around security. As I said before, ACM comes with a pre-bundled security policies and then several compliance frameworks. And this is just to mention a few of the industry standards that maybe some of the customers are using. For example, PCI, I mean, typically relevant if you keep clients' data or customers' data, right? Or if you're in healthcare, HIPAA might be, the thing that you have to kind of comply and things like that. So that's policy governance really for ACM. Again, this function is bundled with ACM. All right, next slide, please, Grant. So let's talk about the last use case for ACM, which is the application delivery. Now, again, this is very useful if you have multiple Kubernetes clusters. I mean, without ACM, you typically need to go to each of the cluster to deploy applications. Like if you have 10 clusters, maybe 5 in dev, 5 in production, you really have to visit one of them to start deploying applications. And again, to see their behavior or how they're performing, you typically have to go to each one of them to do that. Now, ACM solved this problem by allowing you to manage your applications, like from the delivery, monitoring, like moving one app from one cluster to another cluster from a centralized location, right? And also to visually really see what applications are running on which clusters from the same console or dashboard. So in early slides, we talk about the multi-cluster management. Also, I think I mentioned also about attaching labels to clusters, and we can use those labels to control application delivery to our fleet of clusters. And so this is where it's all tied together between cluster management as well as application delivery management. Next slide, please, Grant. So with ACM, we can manage application lifecycle easily across multiple number of clusters. And really the main tool that we use to deploy an application is called Application Builder, right? I mean, and fancy name, but basically it's a web interface with dialog boxes. I think we're going to see this in the demo video later too. For example, when you deploy an application, the dialog box is going to ask you, hey, tell me where is the source of the application. And we support Git, we support Helm, or also we support repository located in object storage. If it's on Git, then the system will ask you, oh, give me the Git URL, right? Give me the branch name. Is it, sometimes you go to a Git repository, then it will be the main branch or maybe production branch or development branch. So when you deploy your application, it's going to ask all these things to be able to deploy it correctly. And we talked about labels earlier. The application builder will also ask you if you want to use any label with the deployment. Perhaps you want to deploy the app on, hey, I want to deploy my Pacman to all my development clusters, right? Or all development clusters in AWS only. Or even better, all development clusters in AWS running OpenShift version 4.8 only. So we can do that with labels. And again, once you're done with this specific deployment to existing clusters with that conditions, with that matching labels, newly created clusters with the same matching labels will also be impacted by this application deployment. So very nice feature. And again, because everything's visual, you can see it, you can view it from the dashboard, so you know exactly what's going on and then what was being deployed to where, right? Okay, so now we talk about subscriptions and channels, right? Again, this is something that helps you to kind of scale your application delivery mechanism or techniques, if you will. So subscriptions allow clusters to subscribe to a source repo or a channel, right? And this channel, again, can be a Git repository, can be a Helm release registry, or any repo located in object storage. So with this function, both developers and IT ops can create and manage applications across environments through basically channel and subscription-based automation model, right? So, for example, if a class, I can set a cluster to subscribe to a channel called Pacman app on GitHub, right? So therefore, the Pacman application then will be deployed or pushed to the cluster that subscribes to it. And should there be any update on the source code, maybe a new approved commit on the somewhere on the tree, then the update then can be pushed to the subscribing clusters by automation, right? And speaking about pushing updates, there are also a couple of neat features. And one of them is time window. I mean, this allows you to specify multiple time windows for maintenance across, any combination of the days in the week. For example, hey, I want to set a time window for an upgrade or maybe deployment of Pacman application that can only occur on Sundays at 1 o'clock Eastern time, for example. I can do that. And also there's another neat feature called rolling update. Again, by specifying a parameters, you can control the rate of update to your clusters. Like for example, if you have 10 or maybe 200 clusters subscribing to the Pacman application, you can define like, hey, at any one time, I just want to push the updates of the Pacman app to just 10% of my 200 clusters, right? So at any time, you'll have just 10% of that 200 being pushed or updated, right? It's pretty cool. And next one, please, Grant. Right, and this is just the continuation of the subscriptions and channel models, right? Again, we're focusing on GitHub since we use GitHub for our application delivery with subscription and with channels. We can treat GitHub as the single source of truth. I mean, using our Pacman app as an example still, we can use GitHub to host the code for Pacman, right, as a repo at GitHub. And if you're familiar with GitHub, any changes on the source code goes recorded, right, gets logged. GitHub will have records of who, what, when is doing the changes for every time there's a change in the source code. So it's easy to audit. So it becomes single source of truth, and also it facilitates kind of DevOps flow in releasing your application. All right, next slide, please, Grant. Okay, so as a recap, we talk about some of the features of ACM. We talk about some of the use cases as well. I'm hoping if you're already running some sort of Kubernetes clusters, you would recognize some of the challenges of running multiple clusters that we talk about today. And I hope that you can use ACM to deal with those challenges. First of all, it can help you accelerate time to production by giving you the ability to better manage cluster lifecycle and application delivery. Right? We saw that using a single console, using everything graphicals, push of buttons, you can really quickly manage your cluster lifecycle and application delivery. And also because of that, we also look at the governance of policies, right, where you can apply certain policies, not only security related, but also other type of policies to make sure that all of the clusters are up to certain standards, right, whether it's PCI or HIPAA, that sort of things. And because all these can be done from a centralized location, hopefully at the end of the day, you'll be able to perform things faster and more efficient and therefore reduce costs. All right. So with that, that's all I have for an overview of ACM. I'm going to pass it to Grant to talk about the next section of the presentation. So over to you, Grant.
All right, thanks, Arif. So my name is Grant Dillavecchia. I'm SA with Shadowsoft. I worked at Red Hat for years and years prior to coming here, and now I'm basically doing the same thing just for Shadowsoft. So I'm just going to cover the last little bit of the presentation. Like Arif mentioned, we have a video, demo video for you guys to run through some stuff. It's a very long video, but we have cut it down to something a little more manageable for this webinar. We will provide the link to the full video, which I suggest you guys take a look at it if you're interested in this at all. It goes into a lot of the details that we are, even though it may not feel like we're glossing over them, we're glossing over them because there's so much information and this thing can do so much stuff. So we kind of pick the high spots and we're going to run through it from there. But with that, we'll just get going. So, one of the keys to ACM and containerization in general with Kubernetes is, application modernization, right? And so this is a buzzword that everyone is talking about, and we gotta, get our apps ready to be on the cloud and all the rest of that stuff. Where ACM kind of fits into that is, as you can see with this particular slide, we have ACM on one side and we have Ansible on the other, right? And then you have your application modernization in the middle, because we all know that our applications don't really do everything, right? They're really just single function things, and they need a lot of support. And that's what all the, IT guys did, right? Is we support the environments for this. So with ACM, or with the full stack that Red Hat provides in this respect, you have ACM to manage the front end, give you your single pane of glass, your control policies, your enforcement, all the stuff that we just talked about. And then you have your application modernization efforts that are going on in your applications inside. And then we have Ansible to deal with everything else, right? And, depending on what everything else means dictates your environment, right? Your physical world, your physical networking, your physical storage, your databases, your load balancers, firewalls, everything else that you can consider, that you can consist of, right? As we all know, when we move stuff into a Kubernetes platform, whether that's something in a hyperscaler, or if it's in our data center, or if it's OpenShift, or whatever it is, there's still a lot of stuff that has to happen outside of that, right? And you usually have to do it yourself, right? We do it, I do it, you do it, everybody else does it, right? The consultants do it. The point behind this with the Ansible automation platform is that we let Ansible do that stuff. And really the key to that is that it makes it easily repeatable, and we can delegate, right? This is where Tower comes in, but we're not going to talk about Tower today necessarily. But the delegation, meaning that you have your primary system engineers, who are few and far between, and they can't possibly do everything. And so this is where the delegation comes in. They write the playbooks, they configure the operators, they do all the stuff. And then your junior engineers, your NOC guys, that kind of stuff can do things. Or with ACM can do it with the Ansible playbooks and so on and so forth. And we're gonna the demo video we have is going to show that. We're going to talk about it even more. So with that, we'll just move on. This is more of a kind of an architectural flow of how this stuff works. And you can see that once you've either provisioned a new cluster or imported it into ACM, you can still deploy your application resources based on the channels that it's been subscribed to. Right now, we've talked about the channels before. In this particular use case, we're using GitHub. And so during the build of this application, you'll have the ability to configure pre and post deployment tasks that are going to be driven or handed to the Ansible automation platform. And then once you configure that, the application will begin to deploy all of its selected resources and whatever else it needs to do that. And then the pre and post tasks will be executed. You'll see in the demo video a kind of a nice kind of description of this as well, what is happening and everything else. You can also refer to any of these tasks inside the topology view in ACM, which will also show in the demo, including job statuses, and it will also provide a direct URL to the job that's actually running. And if you have Tower in your environment, it's a link to Tower basically. But you'll see this in the thing. So what this does is it empowers the developers to build the full end-to-end application without having to spend time running around talking to people and acquiring resources and acquiring approvals and all the rest of that stuff, right? OpenShift and ACM are really designed to give you flexibility and to allow you to delegate to the end users. And in this particular situation, the end users are the developers, right? They're the ones that are writing the code, that need the environments, that need to play and do the things and experiment and try stuff. And every time they want to do something, somebody else has to get involved. With ACM and Ansible, nobody else gets involved. You can let the developers do whatever they want to do. They want to build a new environment, let them build it. They build it. When they're done with it, they throw it away, or they don't, right? With the Tecton, which is the Kubernetes native pipelines that run native inside of OpenShift and Kubernetes, you can let them do everything they want to do without having to constantly worry about, do I have enough resources? Are they breaking the rules? And this is where the policy and governance stuff comes in, right? So it kind of gives you the ability to actually let people do what they need to do. All right, so now we're going to talk a little bit specifically about ACM and OpenShift. So this is the kind of application modernization and how we support it, right? So, you have OpenShift container platform to allow you to run. You have ACM, which allows you to manage. You have Ansible, which will allow you to automate anything that's outside of this particular area. And then you have the observability with Red Hat Insights and all the rest of that kind of stuff, right? So it provides the full stack of how everything works. When it comes to ACM, we did talk about the fact that ACM can manage clusters that are not OpenShift. And when it comes to the observability and the automation pieces should still work, no real problem, right? Ansible can interface with many of the hyperscalers in that respect. The observability, we'll have to look into what that works as you deploy your particular environments out there, and what will actually be able to come back inside that environment. But specifically to OpenShift, this is where it goes. And this slide is it gives you a visualization of where all the software lines up. So if we start at the very bottom, this is your hardware layer, right? We all still need hardware, whether it's in a hyperscaler, it's in your data center, it doesn't matter. It's actually running on actual hardware somewhere. And then on top of that, the big advantage to the OpenShift or Red Hat's offerings is, Red Hat owns the whole stack. So it's RHEL and or CoreOS that's running at the very bottom on top of the physical hardware. And then of course you have Kubernetes on top of that. And in the case with Red Hat, it's just regular old Kubernetes. And then you have the cluster services that are sitting on top of that Kubernetes, right? And we all know what these are when it comes to Kubernetes. These are all the hardware pieces that you need for your applications to plug into, right? So directly on top of the Kubernetes cluster services is where OpenShift sits. And these are the functions that OpenShift provides. We have platform services. So we have the service mesh, we have the serverless builds, we have the CI/CD pipeline, the logging and the chargeback situations. We have the application services, and this is going to be your things like databases, your runtimes, your integration into the business automation, and tons and tons and tons of ISV services, which is independent software vendors. So, these are your F5s and your other tons and tons of, there's just so many of them out there, you kind of can't keep track of them anymore. And as far as how they integrate into the application services. And then we have your developer services, right? So we have your developer CLIs, you have your VS Code extensions, your IDE plugins, your code-ready workspaces, and your code-ready containers. I just want to call out code-ready workspaces and code-ready containers real quick, because many of you may not understand what that is. Effectively, what that is, when developers write code, they need a platform to write it on. And, this has been a problem for as long as developers have been writing code. What do they work on? It used to be that they'd have a Linux box somewhere in your environment and they would write on that. And we try to make that Linux box as close as we can to the production Linux box, right? So that the code actually works in production. Well, that is cumbersome and doesn't really work anymore. So the idea behind code-ready workspaces is your developers can kind of check out a code-ready workspace, which is effectively an OpenShift cluster that gets deployed on their laptop. It's a copy, an exact copy of your OpenShift environment as it is built today in your production environment, and they get a copy of it local. So when they're developing using something like VS Code or VS Studio Code, right? It's talking to that local OpenShift, a single node OpenShift environment that's running on their thing. So they're using all the rules, all the governance, all the policies that you've already put in place. They have it in there. So you have assured that they have as close as possible to a production environment on their laptop. Now, maybe that might not be a big thing because in the scheme of things, it seems like it's kind of simple, but anybody who's been in this business for a while, particularly trying to support developers, can understand how how much value that is, right? So the idea is they write their code in this code-ready workspace, and we know it's going to work because they're running it on a copy of OpenShift. It's just not there. It's just not your production version, right? And so that's a real value. And if you guys would like some more information on this, we can provide this to you, or Reef can from Red Hat, or really anywhere we can get you this information. But it's very nice. Now getting back to the slide, and then you see we have Advanced Cluster Manager, which sits on the very top, right? So it's the top line of where you're mostly going to be spending your days as administrators or managers or anything like that inside your group, right? You do all your work inside here, and you pick which clusters you're going to be deploying it to as you go about your daily life. All right, and so that is now we're going to switch to the demo video. I'm going to get this going. If anybody has any questions, now might be a time to answer them as I get this video up and running. Can you guys see that on my screen?
Yes.
Anybody? Yes. Okay. I can't see anybody's video at this point, so I need someone to say to me, yes, I can see it.
Yes.
All right, so we're gonna head and start this. This is 13 minutes, and then after this, we'll have a question and answer session. If you didn't have any questions right now, we can talk about them in just a minute. So here we go.
And so what we're really going to try to show today is the experience that you might have as a developer that needs a cluster and needs to work with their application, or as a DevOps who needs to manage multiple clusters, like a set of development environments, test environments, production environments, and the hybrid multi-cloud. And so this is where most organizations are landing that are doing cloud today, where it's not one cloud provider, but 2 or 3 or a whole gamut of them in different locations, in different regions around the world, etc. And so my name is Josh Packer. I'm an architect for this product. So we're going to jump at the demo, but I totally remembered I wanted to say something. Troy put a slide up at the beginning where he showed Ansible, he showed ACM, he showed ODF, the OpenShift Data Management Framework, and he showed ACS, the Cluster Security Service. ACM is a glue that brings all of those pieces together. And so even though we're not going to jump into the storage, we're not going to jump into the security today, at least, those are pieces you'll see as we wander through the screens of my demo. And these are all integrations that ACM is bringing together. And then we look toward automating and extending with our Ansible integration. Let's look at clusters. As a developer or as an admin, I may need off the cuff, it's day 0. I have my first cluster. I want to expand into my second cluster. We'll ignore the fact that I have a bunch of clusters here already. I can click in. We've got this nice UI-driven approach where you can pick the cloud service, so the top 3. Then you have 3 on-premise, as well as a 4th, which is this assisted installer we use for our single node bare metals, as well as there's the original bare metal we've supported for a number of releases. The assisted bare metal allows you for a more customized image to be used in the experience. And the idea here is to be rolling out clusters at scale with that space. And so we pick the provider. We'll do one on Google for this demonstration. You use a credential. So I went over here on the credential tab and I preloaded my GCP credential. I actually have an Azure credential and an AWS credential for this as well, and a Tower credential, so that I'm able to talk to the Ansible automation platform. And so I click through here. I need to give my cluster a name. I'm just going to prefix it with my initials, and we'll call it Cloud Field Day 12. Cluster set, we're not going to go into the details here, but you can think of it as a resource group in Azure. It's a way of grouping together your clusters for allowing access to your fleet, or a grouping like a set of production clusters, a set of test clusters, a set of development clusters. It pre-filled in the base domain name from my credential that I had configured, and then I get access to which version of OpenShift. And again, this is a self-managed OpenShift that we're going to be deploying on GCP in this example. This is also curated in the sense that we continually update that for you automatically as new releases come out, as our zstream, as we're patching vulnerabilities, etc. And then you can self-curate it if you want to limit your infrastructure to specific versions of OpenStack. OpenShift. We also have labels, and I'll just touch on this, is everything we do at scale, we do with labels. And so you're going to see as we look at these clusters, there are labels around region and location, cloud providers, what's running on it. But this is also where you're able to define things like, I want this to be a cluster that's part of production. So I might add a label that says something like usage equals production and add that in there. And so you can add line of business type labels. And why this is important is because then you can use these labels on that are on one cluster, 2 clusters, or 1,000 clusters to direct your security and policy compliance, direct your applications, direct your configurations. All of that can be driven at scale using a very simple labeling format, which ends up being very powerful when it comes to fleet management. So I'm going to keep going. I'm not going to get into, I'm going to leave all the defaults, but it's going to go into the US East region here. I'm not going to play with the networking. I'm going to leave the default settings that came with it. You can put the system behind, deploy the system from behind a proxy. And if you have that, you can configure those settings. And then you have automation where you can integrate with Ansible, which isn't set up for GCP at this point. So we'll just hit next and create. And so even though I talked for about 4 minutes, it took me about 20 seconds, maybe 15 to fill the data in. And this system is now going off and provisioning. And so when we start to talk about automation, we introduce this new tab where we can create a template that we're going to use. It's very similar to what we saw in the workflow, and you'll see workflow integration in upcoming releases so that you can take advantage of some of those new pieces that Sean was showing as well. But we give it a name, so we'll do VMware deploy here, if I can spell right. And we'll choose the hub that we want, or sorry, the tower that we want to be leveraging from. And then we're able to pick our Ansible jobs. These are the same job templates Sean was showing before. And so here I can do a ServiceNow ticket that is involved with cluster creation. I can add that in there. I can also add in, so part of the problem with when you deploy a cluster in VMware is that VMware doesn't come with any native DNS integration, and an OpenShift cluster or other Kubernetes, you need an ingress point and an API point. And so I need, in this case, to be able to reach outside of my cluster space into my infrastructure and be able to configure a DNS record. And so here we're going to do a Route 53 record just to show an integration with an Ansible job. You can order these and flip them around if you need to. And you have the objective of being able to do pre and post jobs. So we're going to hit next. We're going to finish this off. But that is not the only way to interface with the system. You can also provision with CLIs, APIs, and GitOps flows. And so we'll do a CLI flow here for the provision. So I've got a very simple OC command. OC is the hallmark for Red Hat that replaces kubectl, although kubectl will work in this instance as well if I wanted to run it. And I'm going to execute 2 pieces of YAML that are going to be deployed. That'll create a couple of resources in the environment, and those are the resources that are used to create a cluster. And so those can be done programmatically. If you want to build scale automation, these YAML can also be committed to Git repos, both public or private, and integrated into the system as well to do the provisioning. Okay, so I was going to import a GKE cluster, but in the interest of time, I'm going to skip that, but just point out that we're obviously Red Hat, we love OpenShift. We do all this provisioning around OpenShift, but we can import anything. And we will import, and you can do policy and application management against other, we often say the star KS, but the other cloud providers. So you see we have an EKS cluster. You can even see it looks different in the distribution versions, but we bring back the details that we know there's 3 worker nodes on it, and we know a bunch of details about it. We've also got the GKE, which I was going to import. I realized I didn't have an AKS in here, but AKS is also fully supported as an import, as well as when you're working with ROSA or OSD, you can import any of those managed service clusters as well. So that'll be my segue into the last 8 minutes, is around applications and our policy and governance and configuration. And so the delivery of applications, delivery of our policies, security policies, and configurations, it's all based on placement. And placement is guided by matching labels. So again, you saw me put usage production as an example. Putting an application on the production system is as easy as defining an application. So we'll define an application here. We're going to do our infamous, maybe not infamous, our very cool Pacman demonstration. So we're going to do a Pacman app. I chose a namespace I wanted to put it in. I chose Git that I'm going to be pulling it from. I've got a bunch of Git repos that have the manifest. So these are all the resources that make up the app available. So I'm going to click on that. Now, because it's Git, it went out to Git, it looked up the branches and gave me some choices. I'm doing an Ansible sample, so I'm going to click there, and I'm going to pick a path. So I'm going to pick Pacman, but you can see, remember we talked about in provisioning pre and post hooks? I've got folders in my Git with pre and post hooks that I want with my Ansible app. I'm going to skip the commit hash. I'm going to skip the tag because I just want the latest and greatest. I'm going to leave the rest of these settings the same, except for my targeting here. So this is the placement, or how I target where I want this application deployed. So I'm going to type app Pacman on here. So the key is going to be app, the value is going to be Pacman. I'm going to hit save. And if you were watching, as I was typing in here, it was filling out details in the YAML piece on the right-hand side. And so this will take a few seconds as it refreshes, but we're going to get topological diagram of what our Pacman app is supposed to look like, as well as an estimate of the clusters that we think it should go to. And so right away, we see it. We've got some routes, a service, a couple of different replica sets that are the actual pods, but we see there's a problem. And we see that the clusters is 0. This is because I put a flag in that doesn't, or a label in, I should say, that's not on any of our clusters. And so this is how easy it is to expand an app from 0. We'll do it to 1, and we'll go from there. So I'm going to pick this AWS cluster, JNP49. I'm going to edit the labels. We can see there's a bunch of pre-populated labels. I mentioned OpenShift. It's got regions. It's got production. It tells you the cloud that it's on. I'm going to add that label, app equals Pacman. I'm going to hit enter. I put it on the end here, and I'm going to save it. And so now I'm going to jump back to my applications. And I'm going to jump into the Pacman ACM that we were looking at. And so automatically, my placement's now gone green. I can see now there's one cluster, and I can see that we're getting ready to try some Ansible stuff. And then maybe we had a problem. Oh, haha. When I configured it, I left out the Ansible connection. That was where Scott was supposed to say, Josh, you missed it. So we'll put the tower JMP in there, and we'll update it. But again, how easily I was able to tell what went wrong. I saw the error in it, as well as see the different pieces. So again, we've got Ansible running as a job. This is going to go out and create, this time we're just going to create a ServiceNow ticket that says we're doing some updates. Then it's going to, the app is going to be activated. So again, we get the launch out where we can go and see. I'm trying to be mindful of time here, so we may not go all the way into ServiceNow and to the pieces. But the point is that the point in all of this is that it's going to run that workflow, which is going to create the ServiceNow ticket. The app is coming online. It's going to run a post job. And this is actually the key part. It's going to reach out to F5 service, and it's going to create a shared route that's going to point back directly to this cluster that I'm just adding to the system right now. And so once that happens, it then becomes live, and I can go to a route and say, click on it, and I would see the application. So we're not quite there yet, but we'll give it a few seconds as it goes through. So my ServiceNow ticket has been created, and now it's launching out to go to the F5 to add the shared route for the system. And so
Josh, to be clear, these are Ansible jobs.
Yes.
That you plucked out of Sean and Richard's catalog and said, you know, F5 looks cool, ServiceNow looks cool, let's just use those.
Exactly.
You wired up a couple of variables out of those, and bang, you're able to integrate with F5 as your application is now moving out.
Exactly. So we're looking for it to create this JHDev, which is again a usable route that is for the application. And so, but I'm going to speed up the demo a little. So I have it on one cluster. I'm going to push it to a second cluster. So let's push it out to GCP2. And again, it's as easy as this case as just adding the application or adding the label app equals Pacman. And the system is going to jump out and going to apply it to the second cluster. But this works the other way as well. If I'm importing a new cluster or provisioning a new cluster, if I add the app Pacman label during that provisioning process, as soon as that's online, this application is going to get stuck there, stuck onto that cluster as well. And so you can see how very quickly this is a very powerful way of pre-configuring both day 0, but also day 1 the system and being able to preset a bunch of apps that you want to go onto a fleet of clusters. And then the same applies in our governance, policy, and risk. And so we have these policies that we apply across the board to our systems, and that again use placement and labels to be able to reach out and figure out which systems do I need to apply these on, what do I have to do.
All right, guys, that was the end of the video. Like I said, that original video was 35 minutes long, and it's great. I mean, so much information in there. So I would suggest that you all get a chance to take a look at it. I found several others, but they're like 2 hours long. So, you know, I guess it depends on how much time you want to invest to look into it, but tons of data and all that kind of stuff. So now we're going to move into the question and answer period for the last 15 minutes. So any questions anybody have? Go ahead. If anybody else wants to, Arif or Nick, hop in there. Otherwise, question time.
And if you can submit your question on the chat, and then we'll address it. We'll give everyone a minute or two.
Here, if there's a question in there from Tyler. He says, when you configure deployment to occur on a given day, is there a separate CR that defines that functionality or a spec param inside the subscription / channel or other? Does that mean
Right,
anything?
yeah. So it's actually a parameter inside the subscription channel. I mean, I didn't know the answer, but I had to look into the documentation just now. But the way that that function is being configured, it's actually under the functionality of the subscriptions and channels. But yeah, so that's the answer.
Okay. I don't see any other questions. Does that mean everybody understands everything? That's awesome.
Great. All right, there's another.
That's a good question. Are we going to
That's a
support
good-
other hypervisors?
Well, I do not know the answer to that. I mean, as everyone knows, recently we just kind of formed officially of our partnership with Nutanix, which is one of the kind of prominent name in hypervisors, hyperconverged kind of verticals, right? But I'm not sure if that is going to be kind of incorporated to one of the support platforms. So I guess we'll watch this space. But yeah, that's always a good question because there's a lot of other hypervisors in customers' data centers, right? But yeah, unfortunately, I guess we're kind of focusing on the most prominent one, which is vSphere. But yeah, I mean, I'll see what I can dig out. But yeah, so far there's no news yet on others. I'm speculating here. Probably Nutanix in the future, hopefully.
Yeah, I can tell you from an unofficial Red Hat perspective, since I'm not officially representing Red Hat in this conversation, when it comes to support, so you can run, OpenShift on all kinds of places. That doesn't mean that it's supported. So it's the question of when it comes to Red Hat saying things are supported or not supported, it generally comes down to, can I call support and will they help me with this? Not will it work, right? I mean, I worked at Red Hat for 7 years and I had all kinds of customers doing stuff that we officially would never support, but they do it anyway and they're running it in production and everybody's happy. So, it's if you want the one button push and it just does everything, now you're going to have to go back to the supported platforms, right? So vSphere, hyperscalers, that kind of stuff, right? Bare metal. And of course, with bare metal, it's RHEL and it's CoreOS, right? That's on, that it gets installed on the bare metal. So it's not a hypervisor in that sense. But yeah, all right. I saw another question. I'm assuming ACM has some type of reporting infrastructure, notification infrastructure, and I'm assuming that it would send an email. I don't think it'll do Slack, but you could certainly turn an email into a Slack message via some other mechanism, I guess. What do you think about that, Arif? Is there anything particular you know about that?
I mean, yeah, I don't think it communicates directly with Slack yet at this point, but I would probably just have a policy. I mean, the way it works in ACM is you have these policies that you apply to your clusters, right? And then at any one time, you can just go to the cluster manually the dashboard manually to just view, which one is which one's red, which one is green, right? But yeah, in addition to that, I think one of the ways to do this is also through Grafana, where you can set custom alert to notify you, like, hey, as of 12:49 Eastern time today, I saw this one and this one being in compliance, right? So that's a way to do it.
Hey, this
Yeah,
is
and
Nick.
it's-
So you actually can integrate Slack in with ACM. Basically, you take the messages in ACM and you'll forward them.
Okay.
So it's a pretty common webhook. That's, I guess, one of the great things about Slack. They just make it easy to do things with. So it can be done. There actually is some documentation I just looked up around out there. It's pretty new. So, but that can be done.
Okay. And as far as ACM doing stuff that's out of compliance, that's kind of, it will initiate things via Ansible. And then of course in Tower, if you're using Tower, then you have more options for controlling what happens automatically, whatever, whatnot. I don't know anybody that's letting it do stuff automatically, right? Without like a person being involved, but I mean, it can do some of that stuff, right? I guess it's kind of, I don't know if I would trust a piece of software to do that for me in my environment, but maybe that's what you want. So, all right, we're going to move on to the next question. I don't think anybody's got to be the idiot, but I would say, so the question is we have a rel user, they've done a lot of rel in VMware, they don't exactly know much about Kubernetes. How do you get it set up and doing stuff like that? I would say that the easiest way to get yourself set up with an OpenShift environment is to use one of the hyperscalers, like ARO for Azure or ROSA for Amazon, or OpenShift dedicated, which can either be on Amazon or on Google. And just kind of stand it up and play with it. It doesn't cost anything to get it up and running. You don't have to buy subscriptions and all the rest of that stuff. It's just a consumption base. So you spin up Arrow and you start paying for it based on what you're using. And that'll give you the option to play around with it. There are also, there's tons of ways to get an opportunity. As far as setting it up in your own environment, you can certainly set it up inside VMware and install ACM and the whole 9 yards. You can do that as well. It's pretty simple to do the IPI installer on your own equipment. You kind of run a command. I don't think we have a demo of that. We might have a demo. I'll talk to Nick and see if we have a demo. Maybe we can send it to you so you can see how that's done. But yeah, it will work for whatever size you need. And it works everywhere. So it'll work in your data center. It'll also work inside all the hyperscalers and all the rest of that stuff.
So just to jump on there, it's really about what type of workloads are you running, right? So this is a common question we get from interested organizations around Kubernetes. Everybody's doing this. Should I be doing this? The answer might be no. The answer is probably yes. But let's figure out what that use case is. let's understand, what type of applications are you managing today, and see if any of those are good fits. Not all applications are a good fit for Kubernetes. Regardless of what all the tech giants will tell you. So that's a big part of how we help customers at Shadowsoft is, defining what's a good use case for you, and then where's the place to start, right? Like a successful Kubernetes journey should start with a well thought out pilot. I would even say a POC is really just around getting comfortable with the platform. What we really need to do is prove a business case that's going to be impactful. So, let us know offline, go take a look at that, Cube Center of Excellence link at the beginning of the presentation, see kind of how we help customers through that. That question is directly related to how we work with customers every day. Should I be doing this? How do I do this? Listen, it's complicated, but we can help clarify it for you.
Yeah, that's one of the things we do a lot with customers. I mean, Red Hat does it as well, but we also do it at Shadowsoft during our engagements, is to help you figure out what are good candidates to move. I mean, you can put anything in Kubernetes, right? You can put virtual machines out there if you want. That's not a good idea, but you can do it. But when you do stuff like that, you make problems for yourself in the future, right? And we've all have painted ourselves into corners at one point or another in our careers, I'm sure, when it comes to technology. And we would like to help you from doing that. I mean, Red Hat wants you to not do that as well, because once you start doing stuff like that, now you can't do other things because you have to support these applications in your container environment that are not great, right? They're not really for that. So there's a lot of stuff, a lot of detail around that. But OpenShift is definitely can work in smaller shops, whatever size shop you need. Most of the time, you are a small shop, but once you get the capability of running microservice architectures and stuff like that, you're not a small shop anymore.
There's an interesting blog article about getting started with OpenShift for the cost of a new Ford Bronco. It may have been written by me. It's on the Shadowsoft blog. Go take a look. Might help you understand, like, you don't have to start big. You can start small.
Yes. All right. Do we have other questions, concerns, thoughts, ideas, anything? Okay.
Looks like we've wore everybody out.
I think so. And we
Or
got it all in
everybody's
on time too. So I'm super happy about that.
Well, Grant, thank you so much. Arif, thank you for presenting. To everybody who attended, thanks so much. We will be providing links to the presentation. Obviously, reach out if you have any questions around ACM or OpenShift or really anything Red Hat related. We'd be happy to help. And we'll be sending out a survey too. So I think it's 2 or 3 questions. Please fill it out. It helps us understand what you'd like to see at the end of the day. So, but thank you all so much for the time, and look forward to talking to you later.